Welcome to qnawire.
For this problem, on the topic of angular momentum and general rotation, we are given the time-dependent position function of an object which moves counterclockwise along the circumference of a circle which has radius r in the xy plane. The object moves with constant speed v, and we are told that the angular velocity omega is equal to v over r. We want to determine the velocity and angular velocity of this object and then show that these vectors obey the relation v is equal to omega cross r. So the velocity we know is the derivative of the position. So to find the velocity vector v, this is simply d by dt of the position vector r. And this is d by dt of r times the cosine of omega t in the I direction plus r times the sine of omega t along the j direction. So performing this derivative, we get this to be minus omega r sine omega t I plus omega r cosine omega t times j. Now we know that omega times r is v, so we can write this as v into minus sine omega t along the I direction plus the cosine of omega t in the j direction. So v here is the magnitude of the velocity or the speed of the object in motion. Now from the right-hand rule, a counterclockwise rotation in the xy plane produces an angular velocity in the positive k direction. So therefore, the vector angular velocity omega is equal to v over r oriented in the k direction. So we can take the cross product omega cross r as follows. So the cross product, we'll use the method of cofactors here. Omega cross r is equal to v over r, which are scalars, along the k direction, and that's crossed with the r vector, which we are given as r cosine omega t I plus r sine omega t along the j direction. So if we use the method of cofactors, that's I jk, and the first vector only has a k component, which is v over r. The second vector has no k component and has I and j components. I component of r cosine omega t and a j component of r sine omega t. The k component is 0. So if we perform this cross product, we get the result to be minus v times the sine of omega t in the I direction plus v times the cosine of omega t in the j direction. And this is familiar because this is the velocity vector we found above. And so we can see, therefore, that the velocity vector v is indeed the angular velocity omega crossed with the position vector r.